Hi there. So today I'm going to show you how to basically take sensor data that's going through the Arduino and actually pipe it up to the web browser so you can see visually what's going on. So the first thing that I've done here is I've created this Arduino sketch that implements this timing diagram for a tsl202r, which is basically a linear CCD. So it's got 128 pixels on it and basically shoots out analog data depending on how much light each pixel detects or photodiode detects. So this is plugged in right now, and if I just look at the data, cover it with a box, and the value goes down, uncover it, the value goes back up. So it's kind of hard to see, what exactly is going on here. Kind of visualize what's going on. So it's a tsl202r, and we're going to touch index.js and HTML. And I'm going to make a node modules directory so that when I install node modules, I install here and not somewhere up the working path somewhere. And we're going to want to install skateboard, serial port, and split. And I'll explain what all these things are doing in a second. Okay, so we're going to use Sublime to edit this stuff. First thing we want to do is get a handle to the serial port. And so we'll list TTY, and this is what we're looking for, TTY USB modem FD121. So create a new serial port. Oops, serial port. And we pass in this guy, dev TTY USB modem FD121. Okay, and when the SP opens, I'm going to call this function. We'll say console log. Let's output the serial port. It's not the node index.js. There it is. Okay, so we've actually connected to it. And I still have this thing running, which I do not need anymore. Okay. Okay, so now we can get a web server going. So skateboard, require skateboard. So here we're going to create a new HTTP server / WebSocket server using skateboard. We pass it the port, which is going to be 1234, the directory that we're going to be serving, and that will be dir name. And when we get a client, this function will be called back with a stream. And so from here we can just do stream pipe into SP. So now if we were to connect to this with the browser, we would actually start streaming all of the data up there. But unfortunately, we're not there yet. So index.js, we run that guy. Let's open index.html, and this is a tsl202r test. Okay, and let's include skateboard min.js, and this gets automatically served by the skateboard project. Script down here so that we can actually create a connection. And basically this is the mirror of the server. So you just say skateboard, and when you actually connect you get a stream. And from that stream you do stream on data function, the console log the data that we're getting from that stream. And you can open up a localhost connection, and uh-oh. Skateboard min.js skateboard. What am I doing wrong? Their name function stream. Huh. Okay, that is pretty weird. But that is not working. I feel like I'm just doing something really stupid. Connected, yay! Let's see if that works. Look at that. It exists. Something strange is happening. Something very strange. Okay. Stream on data. This never gets called. Why? Come on. Hey, look at that. Now we're connected. But for some reason, we're not getting the data. So stream new client. Let's see if that'll work. Hey, we got a new client. Okay, now. Oh, duh. SP pipe into the stream. So I had the stream. I had the stream piping into the serial port, but I needed it to do the opposite. So now, some of this stuff. If we refresh up here, we just get a bunch of data. All the data that we were seeing in the serial port output thing of Arduino. Okay, so now, because of the way that WebSockets work, we can ensure that all the data coming from the serial port is actually, because it's all line delimited, it's like value, new line, value, new line. So what we can do is we can actually use split, wire split, and this is really easy to use. In its basic form, you just call it and it will split by new lines. But you can also pass in delimiters, and it basically creates a through stream that will emit data events as it finds the delimiters. So now it's only going to pipe new line delimited, or it's going to pipe complete values up through the WebSocket. Okay, so if we refresh this guy, it wasn't dead. Okay, so now you can see it's a lot cleaner. It's just data. Alright, and so in here, actually actually in the sketch, I have delimited this so that after it goes through the one cycle, it actually emits an ellipsis, and so that it can say, you know, I'm done with this cycle, do whatever you need to do, like reset indexes or whatever. Okay, so now we can get back over to index.html. And so the idea here is that we're going to render this. We're going to render this to a canvas. So say 512. There's 128 pixels, so like a type would be nice. Height equals 1024, because that is the value, the max value that the analog ADC, analog to digital converter on the Arduino, that's its max value. So having a canvas any bigger wouldn't really make sense. You could go bigger if you did like a scale or whatever, but we're just going to do kind of a linear thing here. Okay, so the first thing that we want to do is trim D so that we get the exact value that we're looking for. And if, let's see here, let's create a variable called index so we know what photodiode we're reading from. If D equals ellipsis, then index equals 0 and return. And otherwise, we need data array. Okay. Index plus plus and data index parse int d10. Okay, so now we have the value going into the data array, and we're incrementing the index, and then we're doing all this sort of fun stuff. So now we can set up like a really primitive render function. And yes, I'm using setEnable. Okay, so 30 frames a second. Canvas document get element ID canvas. Get a 2D context from the canvas. So now we can say canvas width 0, canvas width equals 12, ctx fill rect. Is actually going to be, because we need to loop through all of the data. So data for each and value and IDX. Okay. So now we're going to fill the rect starting at IDX times 3, right? Because 128 times 3 is 512, I believe. 128 times 3, 4. 4, okay. I'm wrong. Get this running again. Okay, times 4, that's going to be our bottom corner, or actually our first x. So, and then our y is going to be 1024 minus v 1024. Actually, make this 3, which is the width, and 1024 is the height. And set the fill style. CTX fill style red. Why not? Okay, and we can. This died again, didn't it? Oh, look at that. It doesn't want to release the cache. Come on, there you go. Okay, so we've got some blinds action going on. The wind's blowing the blinds around, so we're getting a little bit of a variation. If I put the box back over it, it's kind of slow, but I mean, you get the idea. We can visually see what is going on now with the sensor. So with like, I don't know, 50 lines of code or something, maybe less, we've got the sensor data coming out, and we're actually looking at it, which, I don't know, I think that's a testament to how easy this is. And it's all in JavaScript, a little bit of C, mostly JavaScript. So yeah, I think that's about it for now. Just a little introduction to Skateboard, some streaming stuff. Until next time, thanks.